Hi, in this video we're going to talk about object-oriented programming concept and we're going to use Python for the practical part. This video is divided into two sections. In the first part we're going to talk about object-oriented programming and its principles, and in the second part we're going to practice what we learned using Python programming language. Enjoy! Before starting, I'm gonna tell you my story with OOP and how I was able to understand it. The first time that I saw the concept of OOP was when I decided to learn Java. I think I had 60 years old, and I see the OOP as something hard, really hard. And I said to myself, if I learn this, I'm gonna be one of the best developers in the world. But after some days, I quit Java. I hate Java because of the OOP, so I jumped to Python, and the same thing happened. I hate OOP. One of the questions that was running through my head was, why all of this? Why those boring keywords? Classes, interfaces, extend, implements. Why this? Why don't we use functions rather than all of this and live in peace? And I think many of you asked the same question. Tell me in the comments if you asked the same question as mine before. But I was not able to get an answer. I was just using YouTube and Google for learning this because it's free and I don't have money to buy paid course. So I left all of that and I switched to other things. But after I entered university to study computer science, in the second year, we start learning OOP with Java. I know that I have a bad story with this concept, but I say to myself, I think that's the right time to learn OOP. And actually, the teacher that teach us was really great, and he understand well what he said. The first session, the teacher spent an hour just defining what is an object, asking us to give him examples of objects. So, if I ask you to give me an example of an object, what is your answer? You have 3 seconds. 1, 2, 3. Exactly, you are right. A computer is an object, a keyboard is an object, a person is an object, everything is an object. And those objects have something called properties. For example, a computer has a model, a price, a brand, a color. Those are properties of a computer. And the dog also has properties. For example, a name, a color, and a breed. Now, if I ask you about what is the properties of a person, you have 3 seconds again. 1, 2, 3. Your answers are correct. A person has a name, a sex, and an age, and so on. Now, those objects have something called methods. And method is just a function. It's a function actually. It's the behavior of the object. For example, the dog object has a method of run. That's mean that one of the functionality of a dog is running. And the person object has a method of speak and walk, for example. Now, I think you get the idea of what is an object, its method and properties. Now that we have covered what is an object, its method and properties, let's jump to the 4 principles of object-oriented programming. So, OOP have some principles, and think those principles are just some steps or rules that you need to follow to prove that your application or your code based on OOP. And those principles are encapsulation, abstraction, polymorphism, and inheritance. So the first principle that we're gonna cover is encapsulation. Encapsulation is taking all the properties and the methods of an object and group them in a class. Class is a way of defining an object. So rather than said object, we're gonna say class of an object. The keyword class is defining the object. For example, class dog, class computer, class keyboard, class everything, every object. So rather than say the dog, we're gonna see the class of a dog. So the class is a way of defining an object. So, as I said, encapsulation is taking all the properties and the method of an object and group them in a class. So other classes can't know what is inside it. That's mean other object can't see what is inside the dog class. So for example, the object computer or the class computer can't see what is inside the dog object and also can't change the data of this class. For example, when you use the sin method in a calculator, you type sin and you pass to it a number, for example 2, and it returns a value. So all what we know is the sin of 2, but how this function work, or can we change the way the sin method work? The answer is no. And that's the reason of using encapsulation. When we dive to the practical part, you're gonna understand the importance of this concept in your code. Now, let's dive to the second principle. Abstraction. Abstraction is a general concept. Let's give you an example. When I said, for example, person, what do you think it is? So, a person, it may be a student, a teacher, an employee. So the object person is abstract because it have no specific properties or methods. Another example, the object animal was abstract because when we see animal, maybe it is a dog or a cat or a rat. That's why it is abstract, because it was general. Let's give you another example, the last one. So when you hear the object shape, it is abstract because it may be a rectangle or a triangle or a square. That is abstraction. It's general object that some other specific object inherits from it. And that's what brings us to the third principle, which is inheritance. Inheritance was simple. Let's just give you an example. For example, the child inherits some behavior and properties from his parent. That's a great example. So the child inherits the eyes of his mom and the voice of his dad. This is just an example. And it's helping us to not duplicating code. For example, you want to build an application for your school. This application contains some object like teacher and student. We're gonna just take those. So a teacher has properties like first name, last name, ID, hours of work, and salary. And the object student has properties like first name, last name, ID, hours of studying, and grade. Did you notice anything strange here? Yeah, exactly. We are repeating the same properties in those two objects. To fix that, we're gonna create another object called person that has the first name, last name, ID, hours, properties. And the teacher and the student inherit those properties from the person object. So what are we gonna do? We're gonna create another object called person that has properties like first name, last name, ID, hours, and the teacher and the student inherit those properties from the person object. Now let's dive to the last principle. The last principle is polymorphism. And to understand it, we need to know two concepts: overriding a method and overloading a method. So what is overriding a method? Let's see that we have an abstract class called animal, and this class has a method called getSpeed. This method returns the speed of the animal. And we have two other classes, cat and dog. Those two classes inherit from the animal class. So as we already said, when a class inherits from another class, the child class has the same properties and method of the parent class. But in our case, if the dog class inherits from the animal class, the method getSpeed is gonna return nothing. We need to override the getSpeed method and make it return the speed of a dog. So overriding is changing a method of a parent class in the child class, and the same thing for the cat class. Now the second concept is overloading. Overloading is when we override the same function in the same class multiple times. Let's take an example to understand that. We are in a class called showMessage. So this class, his name is showMessage. And this class have some properties. We don't care about properties now. And also, the showMessage class have some methods. The first method is show message. And the second method is show message. And the third method is show message. What is this? It's the same method. No, it's not the same method. Because the first show message method take a string data type in his parameter and it returns something. And the second method take an integer value. And the last method take a float parameter. So they have the same name but different parameters data type. Notice that it's different parameters data type and also different numbers of parameters, because the first show message method, it can take two parameters, for example two int parameters, and the second show message method, it can take three int parameters, for example. So that's the concept of overloading a method. If you understand what is overloading and overriding a method, that's the polymorphism. So the first thing that we're gonna do is creating our first class dog. And as we already said, the dog class has some properties, and to define those properties we're gonna use something called a constructor. The role of the constructor is to initialize the properties of our class. So def underscore underscore init underscore underscore self name age color 2 points self dot name equal name self dot age equal age self dot color equal color. Don't worry, I'm gonna explain what does that mean. So underscore underscore init underscore underscore mean initializing the properties of our class. And the self keyword here represents the instant of the class. So when we use self, that is mean that we want to access to the properties of the class itself. For example, I will write self.name equal name. And that's mean that the name property of the class dog, we're gonna assign to it the variable name that was inserted by the user. When I will write self.name or self.age or self.color, I mean here that I am calling the name property of the class dog, not the name variable that is one of the parameters of the constructor method. Now let's create our first object. We call it dog1 equal the class dog, and we pass to it the parameters of the constructor. When we pass those parameters to the object, those parameters are passed automatically to the constructor. And if you didn't pass them, you're gonna get an error. So we're gonna pass the name, which is Bob, and the age 4, and the color, which is black. Now if I did print dog1.name, dog1.age, dog1.color, we're gonna get Bob, 4, and black. But I am a user, so I was able to see the content of the properties of this class. And we said before that encapsulation means a class or a user cannot see what is inside other classes and cannot change it. For example, we can change the property age of the dog1. So we're gonna just type dog1.age equal to 14 and print dog1.age. As you can see, it's changed. To fix that, we're gonna add 2 underscores before the name of the properties of our class. So self.__name equal to name, self.__age, self.__ color. Now I can see the properties of our class and change them. Now let's add some methods to our class. For example, let's add the speak method. So def speak self and the sound parameter. This method taking the sound variable as a parameter and it's returning the voice of the dog. Return f character, the voice of self__name is sound. I use the f character before writing the string so I can call the variable inside the string value using the brackets. I think you understand. Now let's add another method, which is the speed method. Let's say that we're gonna take the age as a criterion for determining a dog's speeds. So if the self.age greater or equal to 1 and self.age less or equal to 3, return f, so the speed is 10 km per hour. Elif self.age greater than 3 and self.age less than or equal to 10, we're gonna return 40. Elif self.age greater than 10, we're gonna return 20. Now let's print dog1.speak and we pass to it barking, and let's print also the speed method, so dog1.speed. As you can see, we get the voice of Bob is barking and the speed of Bob is 30 km. So that's good. Notice that you can make those methods also private, invisible to other classes, using the to_ before the name of the method.
Now we're going to talk about abstraction. So as we already say, a class considered abstract when one of its method is abstract. And an abstract method is a method that has no implementation. So to mention that a class is abstract, we import ABC, which stands for abstract base classes, and abstract method. So our class inherits from the ABC class. Let's create a class called animal. And the next thing is the constructor, so def __init__ self name age color. So the properties of the class animal are name age color. And let's create a method called getSpeed. So def getSpeed. This method is abstract because we don't know the type of the animal to get its speed. So we're gonna write pass. That's mean that this function didn't do anything, and that's mean that this method was abstract. And that's indicate that the class also is abstract. So to make things clear, the animal class will inherit from the ABC, and we're gonna mention that the getSpeed is abstract using the @sign abstract method keyword before it. Now the animal is an abstract class. Now let's create another class called cat. She also has the name, age, and the color properties. The first thing is the constructor to initialize the properties of our class. Okay? But here we are repeating the same properties of the animal class, so we are duplicating code. To fix that, we're gonna use the inheritance concept. So the cat class inherit from the animal class, and we're gonna do the same to the dog class, because it also have the same properties of the animal class. We need to add a keyword called super, so the super keyword allow us to access method and properties of the parent class, which is in our case the animal class, and use them in the child class, which is the dog and the cat class in our case. So in the constructor of the cat class, we need to pass parameters to the constructor of the animal class. So super.__init__, and we pass to it the name and the color and the age. There are the properties of the animal class. And let's add another property called breed, which is the breed of the cat. So self.breed equal to breed. We didn't pass the breed variable to the constructor of the animal class because the breed property didn't exist in the animal class. So let's go back to the animal class and create a method called getColor that return the color. So def getColor returns self.color. Now let's add a method in the cat class called catColor that return the color of the cat. So we're gonna do super.__color, and as you can see, it's giving us an error because the cat class has no attribute or properties called color, because the color property is private, invisible for other classes. That's why we cannot use it in the child class. And that's the reason of creating the getColor method in the animal class. So we're gonna use it here to fix that problem. So we're gonna do super.getColor, because the getColor method in the animal class was public, visible for all classes. That's good. Now as you can see, we get the color of the cat.
So, as we already said, to understand polymorphism, we need to find out what is overriding and overloading. Let's start with overriding a method. So the animal class has a method called getInfo that returns the name, color, and the age of the animal. And the cat class inherent from the animal class. That means that we can use the getInfo method, but we need to add to it the breed, because now the cat class has the breed property. So we're gonna write def getInfo self and return f super.getInfo, and we're gonna add to it self.breed. So print cat1.getInfo. As you can see, we get the information of the cat and also we get the breed. You need to know something. When a class inherits from an abstract class, you need to override all the abstract method of the parent class. Now let's talk about overloading a method. Overloading is a concept that's not actually existed in Python. If you want to see overloading, just go to Java or C++, but in Python, we just do some tricks to make this concept maybe real in this programming language. So as we already said, overloading a method is creating the same method in the same class, but with different data type parameters or numbers of parameters. In Python, we cannot do that. Let's create a class called calculator, and this calculator have a method called sum. So maybe this sum method can take 2 variables or 3 or 4 or 5. So we need to create a lot of sum methods. Every sum methods take different number of variables. So for example, the first sum takes 2 variables and the second sum method takes 3 variables. But as I already said, in Python, that's impossible. So we just do some tricks. We make a function that take, for example, 3 variables, and we give a default value to all the variables. So if the user enter 2 variables, it's gonna execute with the first 2 variables, and the third variable gonna take 0, which is the default value. We can assign to the variables none if they are object, for example, string or something like this. That's it for this video. Thank you for your time, and please don't forget to subscribe and hit the like button, and please tell me on the comment about something I missed, and see you in the next video.